this video, we try to introduce a so-called perfect number. Okay, so definition. So basically, a perfect number. Is just some integer greater than 1, such that the divisor of n. So all the divisor of n, I should say sum of all the divisor of n except for n is n. Okay. So it explains that. So example 6 has the divisor of 6 is just 1, 2, 3, 6. So sum of the, so I use sigma n to denote d belongs to the divisor, d divides n, then I sum of d. So this is 1 plus 3 plus 6. So this is 2 times 6. Or I should say sum of this is 6. Sum of this is 6. Okay, and also 28. Just you can try this 1, 2, 4, 7, 14, 28. So you sum of this, then you get 28. Okay, so from this point of view, we can say that if n is larger than 1 and sigma is 2n, then I call it perfect number. Okay, so definition, and this is basically common sense. Okay, so now here comes the point. So the proof is theorem. If this is from Euler, so if n is even, then perfect. If n is just 2 to the p minus 1 times 2 to the p. Let me see. I should say p minus 1 times 2 to the p minus 1, and the 2 to the p minus 1 is prime. Okay, and so basically you can choose different p such that 2 to the p minus 1 is prime. Then you just take this n to be your answer. Okay, so here comes the proof. So let me prove this one. So this one is trivial. That suppose n is the form of 2 to the p minus 1, 2 to the p minus 1, then I can take sigma n. So I take sigma 2 to the p minus 1, sigma 2 to the p minus 1. And basically, since this is odd, this is even, and this is just the 2 to the p minus 1 is just the power of 2. So they are coplanar to each other. So I can write down as this. And since 2 to the p minus 1 is prime, so this is just 2 to the p minus 1 plus 1 times 2 to the p minus 1. So we got 2 to the p times sigma 2 to the p minus 1. And the sigma 2 to the p minus 1 is just 1 plus 2 plus 2 to the p minus 1. So it's 2 to the p minus 1. So it's 2 to the p minus 1. Then you can check this is just 2 times n. Right? You can check that. Basically, this is 2 times n. Okay, so this is the first proof. And the difficult proof should be this. Okay, so we need to assume that n is even and perfect. And then we try to say that, there must exist some p. Okay, so the proof is I can write n is just equals to 2 to the k times x, which is x is odd. Okay, so sigma n just sigma 2 to the k times sigma x, and sigma n just equals to 2 to the k, and this is similar. This is just 1 plus 2 plus 2 to the k, so it's 2 to the k plus 1 minus 1 times sigma x, and this is just 2 to the k plus 1 times x. Okay, so from this one, basically you know that this is odd, and this is even. So we must have 2 to the k plus 1 minus 1 divides x. So x equals to 2 k plus 1 minus 1 times some integer y. Okay. But so from this one, then basically you will have 2 to the k minus 1 plus 1 minus 1 sigma x will equals to 2 to the k plus 1 2 to the k minus 1 y. So this tells you that sigma x is just equals to it's just equals to 2 to the k plus 1 times y. Okay, so you see this, we have these two, and here comes the point that so suppose y is larger than 1, then x is equal to 2 to the k plus 1 minus 1 times y. So you see that y divides x, and 2 to the k plus minus 1 divides also divides x, and 2 to the k minus 1 times y also divides by x. So since y is non-zero, so we still have there 1 divided by x. So we can so our sigma x must larger than sum of these two. So we have 1 plus y plus 2 to the k plus 1 minus 1, and 2 to the k minus 1 times y. So our sigma x is just equals to 2 to the k plus 1 y, and minus y plus 2 to the k plus 1 plus y plus 1. Okay, so it's 2 to the k plus 1 y plus 2 to the k plus 1 minus 1 plus 1. So this is which is larger than this. Okay, so from here we know that this is already larger than this. Okay, so there's a contradiction. So which tells you that the y must be 1. Y must be 1. Oh, suppose y is 1, this is 1, then this is 1. So we only have this 1 and this. So which tells you that 2 to the k plus 1 minus 1 must be prime. Okay, so, and also since y is 1, so x is equal to 2 to the k plus 1 minus 1. Okay, so from here what we have is that n is just equals to 2 to the k times 2 to the k plus 1 minus 1, such that 2 to the k plus 1 minus 1 must be prime. And just choose k just equals to p minus 1, k just equal to p minus 1, then you can get this one. You can get this one. So basically 2 to the p minus 1 times 2 to the p plus 1. Okay, so this is our proof. So this is my video for the perfect number. Okay, and before we finish, I said there's an open problem. Is there odd perfect number? Okay, so the answer is I don't know. This is the open problem. Okay, so this is a good video, I think, and be sure to subscribe to my channel. I will see you guys in the next video.